Hi, welcome to this video. Now in this video, we are most definitely going to do some problem solving. So let's just get into the questions and solve them. Now, question number 7, it says to us, the diagram below represents a cross-section of the peaks of Table Mountain, T, and Lion's Head, L, above sea level. Points M and N are directly below peaks L and T. We can see that this is our peaks, peak L and peak T. And then we know that L is Lion's Head and T is Table Mountain. So let's start here. Points M and N are directly below peaks L and M respectively, such that MPN lies on the same horizontal plane at sea level, and the P is directly below C, and then P is directly below C, meaning these are the projected straight lines. These are the most definitely straight lines that act perpendicular to the horizontal lines. So these vertical lines, they act perpendicular to the horizontal line because we can see that CP acts perpendicular to the horizontal line. Now they say to us MN is equals to 3,100 meters, which is provided over here. And the angle of elevation of L and N is beta, and the angle of elevation from T, elevation of T from M is theta. It is given that tan theta is equals to 0.35 and tan beta is equals to 0.21, and we are also provided next to the diagram over there. Now, here's the thing, okay? For a fact that this line is vertical and this line it is also vertical as well as that one, that means these lines are parallel to one another. So for a fact that CP is perpendicular to MN, that means LN will also act perpendicular to MN, and the TN will also act perpendicular to MN solely based on the information provided to us, since well MPN, it is a horizontal plane for these three vertical lines. Now 7.1 it says to us, calculate the ratio of LM is to TN. So now when we have a look at LM it is this side over here, and TN it is this side over here. So if they want us to calculate the ratio, we're gonna have to determine the size of these figures that we see over here. We can see that LM, it is on triangle LMN, and we can also see that TN, it is on triangle TMN. So let us firstly determine the magnitude of LM using the very same triangle that we have just spoke about. So this triangle, which is LMN, we have angle beta, right? We also have this side over here, which is MN. So to determine this side, it's either we use Pythagoras of theorem or we use the trigonometric ratios. So we're not going to be able to use Pythagoras because we don't have Ln. Yes, we have Mn, but we do not have Ln. So we can use sum of the sides of triangle in squared, right? Meaning Pythagoras won't work. Now, let's consider trigonometric functions to determine Lm. So Lm, it is opposite to angle beta. Do we have the magnitude of angle beta in this case? No, we do not have it. But what do we have? This is what we have. We have that tan beta is equals to 0.21. So in order for us to solve number 7.1, we're firstly going to determine the magnitude of beta. We are provided that tan beta is equals to 0.35. So using this, we're gonna use tan arc of this magnitude, which is 0.35. And therefore, when we punch this on our calculator, let me use my calculator, we're gonna say, second, make sure that your calculator, it is in degrees mode. Mine, it is in radians. So let me change it into degrees mode. I'm gonna have to say shift tan 0.35. On my calculator, I get 19.2. 9 degrees. So this is the magnitude of angle beta over here. So let me determine the magnitude of LM. LM, it is opposite to beta. Sorry about that. LM, it is opposite to beta. And then I can use this angle. I can use side MN. So how? Remember, beta, it is opposite to this side. So to determine this side, I'm going to say opposite this angle because I'm provided with this angle. I'm going to say opposite. This angle is opposite to this side, and this angle, it is adjacent to this side. It can't be hypotenuse this side because it is not opposite to 90 degrees. The hypotenuse, it is ln, since well it's opposite to 90 degrees. So that means to this angle, I am looking for opposite side. I am provided with the adjacent side. You go to your SOHCAHTOA, SOHCAHTOA, right? So we are looking for opposite and adjacent, right? Opposite and adjacent, opposite and hypotenuse, adjacent and hypotenuse, opposite and adjacent. This is what you are looking for. We are looking for opposite, which is LM, and adjacent, which is MM. Opposite, adjacent is this one. So that means we're going to use tan beta, right? We're going to say tan beta is equals to opposite, which is LM, divided by adjacent, which is MN, right? Remember, we are looking for LM. So we're going to make, remember, this is the same as tan beta over 1. So we're going to cross multiply. We're going to say LM multiply by 1. It's going to be LM. And then we're going to say MN multiply by tan beta. It's going to be MN tan beta, right? So now, because you're looking for LM, let us do our substitutions. What is the magnitude of MN? MN, it was provided to be 3,100 meters. Tan beta, the thing is, you can just substitute your angle over there, or you can just substitute 0.35 over there because we were also provided tan beta is equals to that, you see. So it's, you know what, you can substitute 0.3. Even if you substitute your tan beta over here, your beta over here, which is 19.29, it is still fine because now I see it's going to be easier even if you substitute 0.3. So that means you're going to say 0.35 because remember, tan beta is equals to 0.35. It was provided. Or you can just substitute, you can just say tan 19.29. It is still fine in that way because I have already determined the magnitude of beta. And therefore, when I punch this on my calculator, I'm going to say 3,100 times 0.35. And then this is what we get. We get 1,085 meters. So this will be the magnitude of LM, right? This side over here. So let me write it over here. Here we have 1,085 meters. Okay. So remember, we are looking for ratio of LM to TN. We needed to calculate this first. So now let's determine the magnitude of this thing TN. So to determine the TN, which is this side of this triangle over here, remember we are also given tan theta is equals to 0. Oh, here we're supposed to use 0.21, not 0. This is for theta, right? This is for theta. And the beta is this one. So here we're supposed to use 0.21. Okay. Let's not mix them up. So here we're supposed to use, no, it is still correct. Yes, it's still beta over there. So let's use 0.21. It is still beta over there. Now we see. So now, let me use this. Was supposed to be 0.21. Let's not mix them up, right? Let's not mix them up for the sake of getting good grades. So we're gonna say 3,100 multiplied by 0.21, right? It's gonna be how much? It's gonna be 651. It's gonna be 651 meters. Okay, so here it's 651 meters. Now let's go for this one then. So tan TN, we're going to use theta, right? Because TN, it is in this triangle, TNM, TNM. We use theta now, okay, not beta. So now that means to determine this, we are given tan theta, we are given side MN. Again, MN is a common side for both triangles. So let's determine TN. So we're going to use which trig function? Remember, we are given the opposite. We are looking for opposite. We are given the adjacent to the angle. So that means we're going to use tan what? Tan theta, right? Because you're talking about angle theta. Tan theta is equals to opposite in this case will be Tn divided by adjacent in this case will be Mn, right? And therefore remember this is the same as tan theta over 1. And let's cross multiply. We're gonna say Tn multiplied by 1. It's gonna be Tn, which is equals to Mn multiplied by tan theta. It's gonna be Mn tan theta, right? Right. So now, let me switch this thing off before it disturbs us. So now, let us do the substitutions. Now, what is the magnitude of Mn in this case? Mn, it is provided to be 3,100 meters, and therefore tan, remember, our tan theta in this case is equals to how much? Our tan theta in this case is equals to tan theta 0.35. Yes, 0.35. And therefore now let us punch this on our calculator once more. I remember we got it now, I erased it. So it's gonna be 1,085. Yes, meters. So that means this side, which is Tn, we have 1,085 meters. Okay, so we calculated the magnitude of beta. You can also calculate the magnitude of theta by doing the very same procedure and substitute your angle over there. So this is not that necessary, but you can also do it in that way. Okay, I just never thought that when we get over here we'll still use the same thing, which is tan beta. Okay, but you are safe doing it in this way. Now we have the magnitude of Tn over there. Now let us calculate the ratio of Lm is to Tn. So now the ratio of Lm is to Tn. It is provided to be equals to how much? What is the magnitude of Lm? We have determined that Lm is 651 meters is to what is the magnitude of Tn? It's 1,085 meters. So remember, when we are looking for a ratio, we divide with the smallest number. So the smallest number over here is going to be 651 meters is to we don't have because I'm dividing, and even on this side I'm going to divide by 651 meters. So now let me take it over here. Lm is to Tn is going to be equals to how much? 651 divided by 651, meters cancels meters, so that means here we're going to have 1 is to meters cancels meters. So what is 1085 divided by 651? We get that it is 1,67. Therefore, this will be the final answer for question number 7.1, where they said they wanted us to calculate the ratio. Right. So now we move to 7.2. They say to us, a cable car C, this is the cable car they are talking about, traveling from the top of Table Mountain. Remember, this is Table Mountain. The car is traveling from the top of Table Mountain at point T, follows a path along TCM, It is traveling downwards, most definitely from the T. So 7.2.1, it says to us, calculate the angle formed between the cable and the vertical height, Tn. So what is the name of the angle? It is M angle Tm. M angle Tm. This is the angle of interest. This is the angle that we actually want to determine, right? So now, how are we going to determine this angle? We're going to use this diagram over here. Already, we have managed to determine the length of Tn. We said the length of Tn is 1085 meters. So that means on this side, we have 1085 meters. So our question is, how are we going to determine this angle over here? We're going to use trigonometric ratios. So in this triangle, this bigger triangle, which is called TMN, we're going to use it to determine that. So we have this side over here, we have this side over there. So we need this angle. So now this angle, it is opposite to this side which is provided. This angle, it is adjacent to this side over here. So remember, I said to you over here we have 90 degrees. So that means TM will always be a hypotenuse. So that means we're going to use opposite and adjacent. You go back to your soccer, TOA, right? What are we looking for? We are looking for opposite and adjacent. We are looking for opposite and adjacent, meaning the trig ratio that you're going to use is tangent. So that means you're going to say tan of this angle, which is MTN, which is M angle TN is equals to how much? Tan its opposite. Our opposite to this angle is side MN. So we're going to say side MN divided by our adjacent to this angle, adjacent next to it, the side which is next to this angle is TN over TN. And therefore, what are we looking for? We are looking for angle TN, right? So we're going to make angle MTN subject of the formula. So M angle TN as a subject of the formula. Let's get rid of tan. We're going to say second function of tan of what? Of this, which is MN over TN. And therefore, let us do our substitutions. Second function of tan. So what is our MN? Our MN, it's 3,100 meters. Then what is your TN? The TN, it's 1085. This will be our TN. And therefore, now let us punch this on our calculator and correct to 2 decimal place if that's what we need. Where's my calculator? Okay, there it is. Going to say second function, tan, open fraction, 3100, right? Divide by 1085. And therefore, on my calculator, this angle, it's 70, 7 to 2 decimal places, 71 degrees. Okay, so therefore, I'm going to say my angle, it's M. Angle TN will be equals to this magnitude over here. This is 70 basically, okay? Here we have 70, 71 degrees. This is the angle. Now, 7.2.2, it says to us, if the cable car C travels along the cable such that TC, let's go and look for TC. Okay, let me use a clean page. If the cable car C travels along the cable such that TC is equals to 400 meters. That means from here to there, we have 400 meters, right? Calculate the height of the cable car above sea level at that instant. So that means we want to calculate this side over here, the height of the car. Remember, this is the height of the cable car from Table Mountain T, point T, from the peak of Table Mountain. This car traveled at this point, it was traveling towards M, right? It was traveling towards M. So when it reached this point, which is 400 meters on this plane, when it reached this point, they want us to calculate the height of this cable car from the horizontal plane to the cable car where it is located. So we want to determine CP. So our question is, how are we going to determine the CP? The CP, it is located in which triangle? It is located in triangle CPM. M. That's where CP is located. So that means we need side CP. If we need side CP, do not forget this triangle, it is a right angle triangle because we have 90 degrees over there, right? So that means this will be our hypotenuse and this will be our sides, CP and MP. So our question is, how are we going to determine this side, which is side CP? We can use our angle over there because this angle, it is in the very same triangle that we are interested onto, theta, right? So remember, we are given that tan theta is equal to 0.35. So in order for us to do that, in order for us to do that, this is the actual simplest way to do it, okay? This TC, like, you see, we are provided with TC. Oh, okay. Let's say you say, I want to use MP. Remember, this is not NP, right? This side over here, it is not MP, it is MN. Let's not confuse that, okay? It is MN, it is not MP. So that means we do not have this side, we do not have this side, we do not have this side, and this side is what we are looking for. So then what are we going to do? Now, this is what we are going to do. We can calculate the hypotenuse in this triangle, MC, okay? We can calculate MC. After getting MC, we use this angle and MC to determine CP. Let's determine MC first. So 7.2.2, how are we going to determine MC? Remember in this previously, right? Previously, there are many ways to determine this. Previously, we want MC, we want MC, right? But firstly, we're gonna have to determine TM. Previously, we have determined that TM, we have determined that in this bigger triangle, TN, we have also the magnitude of MN. We can use Pythagoras of theorem to determine TM, okay? Remember, here we have this side, we have 1085 meter, and then we have this side over here. So let's determine TM. So we're gonna say TM squared is equals to how much? Is equals to TN squared plus MN squared. We are using Pythagoras theorem. So now, what is the magnitude of Tn? The magnitude of Tn is 1085 squared. Plus, what is the magnitude of Mn? Is 3,100 meters squared. Now, when we punch this on our calculator without wasting any time, remember this is hypotenuse, right? Tm, because it's opposite. Remember, we said here it's 90 degrees. So we're gonna say 1085 squared plus 3100 squared. And then let's root it under the root sign. We get Tm squared. Let me do it like this. And then under the root sign, we get that Tm is equals to 3,284, comma, two decimal places, comma, 39 meters. So now we know this side. Now we know this side over here. Okay. Now we know this side over here that is 3,284,39 meters. So we're going to determine this side over here. You're going to determine this side over here. We're going to determine this side over here. We're going to determine MC. So we're going to say MC is equals to how much? Is equals to the bigger side, which is the red side. The bigger side in this case, it's 3,284,39, subtract the smaller side, which is 400. which was provided, 400 meters. And therefore, what will be the magnitude of MC? We're going to say 3284, 39 subtract 400. We get 2,884,39 meters. So now we managed to get the side of MC, which is this. Now everything is getting or is falling to the place. So we have this side over here, right? Now in this side, which is MC, remember we are interested in this triangle. We are interested in this triangle, right? We want to determine CP. So we have MC, we have theta over there. Let us determine the magnitude of theta, okay? Because we can't use tan because we don't have to use our hypotenuse. So to determine the magnitude of theta, we're going to say tan theta, it was provided to be equals to 0,35. Therefore, theta will be second function of 0,35 on our calculator. So now, what is the magnitude of theta? We go second function 0,35. It's 19,29 degrees. Now we know this angle over here. So let us determine CP. So we know this angle. We know this side. We are looking for this side, which is CP. So we're going to say this angle, it is opposite to this side. This angle, this is the hypotenuse because it's opposite to 90 degrees. So you go to your saw, car, to, what are we looking for? To this angle, we are looking for opposite and hypotenuse. So where is opposite? There is opposite and hypotenuse. So that means we're going to use sine. So meaning sine for cosine, sine theta, this theta right, this sine theta is equals to opposite, which is CP to that triangle, CP opposite over hypotenuse, which is MC. So remember, this is the same as sine theta over 1. We cross multiply. 1 multiplied by CP will be CP. MC multiplied by sine theta will be MC sine theta. So let me take it here. So now CP will be equals to, let us do substitutions. MC, we got MC to be equals to this magnitude over here, which is 2,884,39. And therefore multiply by sine theta. We just figured that theta is equals to 19,29 degrees. 29 degrees. And therefore, CP will be equals to how much? Let us punch it on our calculator. We're going to say 2,884,39 multiplied by sine 19,29. And then we get our CP to be 952,86 meters. So you can just correctly conclude by saying, therefore, remember, they wanted us to determine the height. Height of the cable above sea level at that instant is this one, okay? Height of the cable car above sea level at that instant is equals to 952,86 meters. and therefore this will be our final answer.